Okay, this lesson is about types of chemical equations. The five main types of equations that you'll be learning about include synthesis, decomposition, single replacement, double replacement, and combustion. Let's talk about each one in turn. Just a quick intro to each kind. First, synthesis reactions. Like the word synthesis means to make something or create something, a synthesis reaction is when two or more substances react to form a single substance. Very easy to recognize because there's only one product on the right side of the arrow. A general pattern could be like this: A plus B makes AB. A decomposition reaction is, in many ways, an opposite of synthesis. Decomposition is when a single compound is broken down into two or more simpler products. Decomposition is also really easy to recognize because they have only one reactant on the left side of the arrow. For example, AB decomposes to form A and B as separate elements or separate compounds. A single replacement reaction, sometimes referred to as single displacement reaction, is when atoms of a more reactive element replace the atoms of a second element in a compound. Notice that the one element that's doing the replacing has to be more reactive. It's pretty easy to recognize because a single element and a compound are on both sides of the equation. So for example, if A, B, and C represent elements, or even, they'd have to be elements in this case, AB, a compound, reacting with C, a metal, yields AC, a new compound, plus B, a displaced metal, a replaced metal. So apparently C is more reactive than B, and it kicks the element out. A double replacement reaction occurs when two compounds more or less switch partners. It's really easy to recognize because this has only compounds on both sides of the equation. Frequently these will be ionic compounds or possibly an acid, but look at the way these work. AB plus CD yields AD plus CB. They've traded dance partners. Also notice that A and C are written first and B and D are written second on both sides of the arrow. Lastly, our main type that we'll learn is a combustion reaction. We want to limit our discussion to oxygen reacting with a hydrocarbon to form carbon dioxide and water. A hydrocarbon is what it sounds like, a molecule made out of hydrogen and carbon, where X and Y can be any whole numbers. Now technically, any reaction of a substance with oxygen that is exothermic, think like burning or exploding, is combustion. But we want to mostly limit our discussion to combustion of hydrocarbons. An example to follow would be CXHY, whatever X and Y are, reacting with oxygen to make CO2 and water. So the plus O2 yields CO2 plus water part will be the same every time, and the hydrocarbon on the left will change depending on what we're working with. I'm hoping that you get to take part in a sorting activity in which you will sort the strips that you're given into different categories of equations and then let your teacher approve your work and then copy it into the notes on your paper. We'll see if we have time. I hope we do.